What if the AI you rely on for research will believe anything you tell it? Not because it is broken, but because of something fundamental about how every major AI model is designed. I tested 3 of them with a fake Wikipedia article I wrote myself, and every single one treated my fabricated facts as real. Here is exactly what happened. Before I show you the test, let me be clear about what these AI models are actually doing when you give them a document to read. They are not cross-referencing the internet. They are not running a fact check. They are pattern matching the text in front of them against billions of examples of text they were trained on. If the writing looks authoritative, the model treats it as authoritative. Researchers have a term for what I triggered in this experiment. It is called context poisoning. The idea is straightforward. When you insert text into an AI prompt, that text becomes part of the model's immediate context window. The model weights that context heavily, sometimes more heavily than its own training data. So if the context is wrong, the model's output will be wrong too. Here is how I built the fake article. I chose a real but obscure historical topic, specifically a minor 19th century engineering project. I kept about 60% of the details accurate so the article would feel legitimate. Then I inserted 3 specific false claims. A fabricated name for the lead engineer, an incorrect date for the project's completion, and a made-up technical failure that I described in confident, encyclopedic language. The writing style was the key ingredient. Wikipedia has a specific tone. Passive voice, hedged language, citation-style footnotes even when those footnotes are empty. I matched that tone exactly. When an AI model sees text that structurally resembles a reliable source, it responds to the structure as much as the content. Model 1. I pasted the fake article into a prompt and asked for a detailed summary with key figures and dates. The model returned a confident, well-organized summary that repeated my fabricated engineer's name, the wrong completion date, and the invented technical failure, all presented as established historical fact. No caveats. No uncertainty. Just clean, authoritative misinformation. I then pushed further with Model 1. I asked it to elaborate on the engineering failure I had invented. It did. It added plausible-sounding technical context that was entirely generated by the model itself, built on top of my false foundation. This is the compounding problem. One false input does not just produce one false output. It produces a tree of false outputs, each one referencing the last. Model 2 is known for being more conversational and for pulling from live search in some configurations. I ran the test in a configuration without live search enabled, which reflects how most users actually interact with AI tools inside documents or internal tools where the model only sees what you give it. The result was nearly identical to Model 1. All 3 false claims were accepted and repeated. One small difference with Model 2. It added a single line at the end of its summary that said something like, for the most accurate details, consider verifying with primary sources. That is a boilerplate disclaimer. It did not flag any specific claim as uncertain. It just absorbed the false article and offered a general hedge at the end, which is far less useful than it sounds. Model 3 has a reputation for being cautious and for acknowledging uncertainty more frequently than the others. I was genuinely curious whether it would push back. It did not reject any of my false claims. It did, however, add the phrase according to the provided text twice in its summary. That is a meaningful difference, but only if the reader understands what it implies. Most readers will not stop to question the source of that text. Across all 3 tests, not one model asked where the article came from. Not one model flagged that the engineer's name I invented does not appear in any historical record. Not one model noticed that the date I used contradicts the broader historical timeline I had left accurate in the rest of the article. The models were not lazy. They were doing exactly what they were designed to do, process the context they were given. This is not a bug unique to one company or one model. It is a structural property of how large language models handle in-context information. The model's job during inference is to be helpful with what it has been given. Skepticism toward the input is not built into the base behavior. Some models have safety layers that try to catch dangerous content, but factual accuracy of a plausible-sounding source document is a different problem entirely. Why does this matter outside of a YouTube experiment? Think about how AI is being used in real workflows right now. A legal team feeds a contract summary into an AI to extract key clauses. A journalist uses AI to process a press release. A student pastes in a source and asks AI to help them write about it. In every one of those cases, if the input contains false information, the AI will help that false information look more credible and more complete. There is also a second-order risk here. When AI output gets published, screenshotted, or cited, it gains the appearance of machine-verified authority. People see an AI summary and assume some automated fact-check happened. The experiment I ran shows that assumption is wrong, and it is wrong in a way that is very easy to exploit. So what can you actually do about this? I tested 4 prompting strategies that increase the chance an AI will signal uncertainty rather than just repeating your input. The first one is direct. After you give the model a document, ask it specifically, which claims in this document are you unable to verify from your own training data? That single question shifts the model's posture from summarizer to auditor. The second strategy is to ask the model to identify the single most questionable claim in the document and explain why. Models tend to perform better when they are asked to focus on one target rather than evaluate everything at once. The third strategy is to provide the document and then ask a follow-up question that would require information not present in the document. If the model answers confidently, it is confabulating. That is a red flag. The fourth strategy is the most counterintuitive. Ask the model to argue against the document. Tell it to find reasons why the claims might be wrong. Models are better at generating counterarguments than at spontaneously doubting input. This does not catch everything, but in my tests it surfaced 2 of my 3 planted false claims where a straight summary caught 0. None of these strategies make AI perfectly reliable for fact-checking. What they do is change the distribution of errors. You move from a model that confidently repeats false information to a model that flags more of its own uncertainty. That is a meaningful improvement for anyone using AI in a research or editorial workflow. The broader takeaway from this experiment is not that AI is useless or dangerous in some abstract sense. It is that AI models are mirrors. They reflect the quality of what you put into them. A well-sourced, accurate document produces useful output. A fake article produces a convincing fake summary. The model cannot tell the difference on its own, which means the responsibility stays with the human in the loop. I think the most important habit anyone can build right now is to treat AI output the same way you would treat a very fast, very confident intern who has never fact-checked anything. Useful, capable, worth listening to, but not the last word on whether something is true. If this experiment gave you something to think about, the like button is right below this video and it helps this channel reach more people who want honest AI coverage rather than hype. Subscribe if you want the next experiment, which will test whether AI models can be prompted to catch their own hallucinations in real time, using nothing but clever follow-up questions. That one gets interesting fast.